So let's start with the parts. This is the star of the show. This is the ESP32, and it is a very powerful if small device. Just to show you the size of the thing, this is a pair of scissors. So it has a bunch of things known as pins along the long edges here and there. They are all digital, but they can be used for analog things as well. Some of them are used for giving power, like this one here is called V5. This is where the 5 volts goes out, and this is 3V3, and that is where the 3.3 volts goes out. It also has pins called GND. Some of them are called GND. Over here we have a GND. That is the ground plug that you need to have for a circuit to work. This is the processor here under this cover. This is the USB connector, and then these two buttons can be used for booting the device and resetting the device. On the other side it looks like this, just a bunch of standard sized pins. There are 10 pins per inch, so this is how the form factor happens. And all you need to do is to find a proper pin and then plug your sensors to them. For example, if you are using devices that use the I2C bus, you need to always use pins number 21 and pin 22 to connect your SDA and SCL wires. You don't have to worry about any of this, you will understand it as we go further. And also for the GPS sensor to work, you need to use the pins 12 and 13, which are somewhere here, probably over here. No, that's 12 over here. Yeah, over there actually. That's 12 and 13. So you need to know where to put your stuff when you are connecting parts to this device. And next, the BMP280. So this is the air pressure and temperature gauge, and as you can see, it is way smaller than even the ESP32, and that's a good thing because the less space you use on your devices, the smaller you can make the complete box. It has two pins called VCC and GND. These are important because all the pins have to be powered through the VCC pin, and they have to be aligned from the ground pin to the ground pin on the Arduino or ESP32, depending on whether you have an IoT device or a local device. You also have two other pins. One is called SCL and the other one is called SDA. That is the I2C bus, where the SDA is called serial data and SCL means serial clock. And these have to be connected to pins 21 and 22 unless you want to programmatically put them in a different place. But the default for this I2C bus is always 21 and 22. The device itself is tiny. The shiny little thing with the hole in it. This one here is actually where the magic happens. Air pressure is measured by letting air in through that hole, and it also tells you the temperature. Next up, the GPS sensor. So this is the one that is called Neo 7M. I also have Neo 6Ms, but I don't know what the difference is. The actual device is this part here. This is the sensor and processing unit, and this part here is just the antenna that has to be connected to this tiny point in here. This one has only 4 wires. One is called VCC, as always, for power. One is called GND for the ground. That makes the thing work. And then you have the pins TX and RX. That is for serial movement of data. TX is for transmitting and RX is for receiving. This thing is also receiving data from ESP32. There's a tiny battery in here that you have to charge. When you first get these devices, they do not work. until you give them 5 volts for a certain amount of time, so that the tiny battery gets charged, and after that it starts to work. So it's very easy to connect. All you have to do is to take the wire TX and put it into pin 12 on the Arduino, ESP32, sorry, and then you take the RX pin and you put that into ESP32 pin number 13. That's the basic setup of this device. Very easy. And this is your basic Hitachi copy clone LCD 1604, and the 1604 means 2004. That means that we have 20 characters going this way, and we have 4 lines of data that we can display. So this one has 80 characters, and as you saw in the beginning of the movie, this is where you are locally displaying your values, so that it's easier for you yourself to use the device. On the other side, you can see that there is again an I2C bus. See, we have ground and we have voltage, and we have the same SDA and SCL lines that are used to pass data to this device. And again, they will be connected to the same pins, the 21 and 22, as on the ESP32, as the temperature gauge. But because this is an I2C device, this has a different address from the BMP280. That one is actually OX27, and this is OX03. So you could have basically almost an unlimited amount of devices using the I2C bus, because they all have a different address. But usually any device that you build will usually have a maximum of 5 devices connected to it. So the last thing to show you is the breadboard. This device is your breadboard. It's also known as a connection testing plate, and it is one of the best inventions for making stuff like this for testing purposes or making prototypes, because it's very easy and very fast to connect things using this breadboard. You can see that there's 2 rails. We call these power rails. This is the one power rail with a blue for the ground and a red and a plus for the power. So you have ground on the blue and you have power on the red. And on the other side you have a similar but unconnected power rail. This is not connected to this, and this is not connected to this. That means that since we need 3.3 volts for the BMP280 and we need 5 volts for the display, we can take 3.3 volts from the ESP32 and put it here on the left hand side, and then you can take 5 volts and put it here on the other power rail for your display. And as you can see here, you have holes, 2 holes next to the SDA pin and 2 holes next to the SCL pin. That's where you can plug in your lead that comes from the Arduino or ESP32. So you would put your wire called wire 21 into your SCL connection and wire 22 to your SDA connection. And you would still have another hole here to use for the display. So you can take a wire from ESP32, put it in here, and then take the same wire out to a different device, and they will work together just fine. And in here you have 5 volts for the GPS, you have ground for the GPS, and the RX and TX that go into pins 12 and 13. And I will now show you how the actual device looks now that we have seen all the parts. Alright, I know that this will look slightly messy, but bear with me and I will explain to you how things actually work. Here we have the ESP32, and in here we have the pins that go from 12 and 13 to the RX and TX pins on the GPS sensor. Let me manually focus this because this is much better. And on the other side we have the pins 21 and 22, and they go here into the rows 21 and 22. So you need to understand that these power rails go this way, but these plug-in holes go this way. So anything that I plug into 30A is also available for 30B, 30C, 30D, and 30E. In here I have 21 and 22, and that's how I am able to take the 21 and 22 and lead them here for the BPM at 280, and I can also share it here for the display. So in principle this is a very simple but still rather powerful IoT device, because the ESP32 has been programmed to check out the location data from here and check out the air condition from here every 10 seconds, and then write that information onto the internet into a text file, and I will cover that in a separate video in a moment. But this is how you build the device, and if I close the box like so and give it power, you can see how the LCD starts, how the wireless LAN is connected, how the BMP280 is started, and then it goes to boot the GPS, and it will take X amount of time to boot the GPS, and then, as I showed you before, it would need to be away from any heavy structures such as my lab, which is built in the 6th floor, so there's probably more iron here that this device could tolerate. But sometimes it does pick up the latitude and longitude. It's really funny why it does it. And that's all there's to it. This is how you build an IoT device.